Hi students, now we are going to solve problem number 8. Calculate the mean free path of air molecules at STP. The diameter of nitrogen and oxygen molecules is about 3 into 10 power minus 10 meter. Here the diameter of the molecules is given. Then indirectly the temperature and pressure at STP is given. We have to remember. So first at STP, standard temperature and pressure. So the temperature of the gases is taken as 0 degrees Celsius, or this is equal to 273 Kelvin, and the pressure is taken as 1 atmosphere, that is equal to 1.031 into 10 to the power of 5 pascals or Newton per meter square. Then I will write the diameter, small d. So the diameter d is equal to 3 into 10 power minus 10 meter. Now for this we require Boltzmann constant. The Boltzmann constant will be usually given in the question paper itself. You need not remember, but I will write. So this is equal to 1.38 into 10 to the power of minus 23 joule per Kelvin. Okay. So we have studied mean free path is defined as what? The average distance travelled by a molecule between any two successive collisions. So the mean free path is given by the equation. Okay, the mean free path is given by lambda. Lambda is equal to k into t divided by square root of 2 into pi d square into pressure P. Is it not? K is Boltzmann constant, T is the absolute temperature at STP. Here P is the pressure at STP. Here d square is the diameter square. Okay. Then square root of 2 is constant, pi is constant. Therefore, now we have to substitute the values. So lambda is equal to k into t. So k value is already written here. So 1.38 into 10 power minus 23 into temperature is 273 whole divided by square root of 2 is 1.414. 1.414 multiplied by pi is 3.14 into d square. Here d is 3 into 10 power minus 10. So 3 into 10 power minus 10 the whole square into P, the pressure. So the pressure is 1.031 into 10 power 5. So now lambda is equal to, now all the 10 powers I will keep it at the end. Remaining numbers we will multiply. So this is 1.38 into 273 into 10 power. Here there is a minus 23 into, here 10 power minus 10 the whole square will be 10 power minus 20. But when it comes up to the denominator it will become 10 power plus 20. So into 10 power plus 20. Then here there is 10 power plus 5 in the denominator. It appears as 10 power minus 5. So into 10 power minus 5 in the numerator. So whole divided by, now the product of the numbers 1.414 into 3.14 into 3 square is 9 into 1.031. So now I am going to calculate. So if I calculate means the numerator 1.38 into all this 273. So this will be equal to 3. That is 1.38. 1.38 multiplied by 273. So 273. So this is equal to 3.76 or 376. Okay. 3.76 into 10 power 2 is coming, but I have written 376 multiplied by, you check the powers of 10 now, minus 23 and minus 5 will make us minus 28. But here 10 power 20. So remaining is 10 power minus 8. That is in the numerator. Similarly, I am going to multiply the denominator. It is coming as 41.2. So if you multiply all this number, it is coming as 41.2. This ratio I will find out once again. So 376 divided by 41.2. So 376 divided by 41.2. So this is coming as 9.126. So this is equal to 9.126 into 10 power minus 8. Therefore, the mean free path lambda is equal to 9.126 into 10 to the power of minus 8 meter. So this is the expected answer. Okay students, so here now in this only you have to remember the formula correctly, and standard temperature and pressure you have to assume temperature as 273 Kelvin and pressure as 1 atmosphere. Also it is better if you remember the value of Boltzmann constant also. So only if you substitute means we get the answer as 9.126 into 10 power minus 8 meter. I hope you must have understood well. Fine.